This lesson's on section 7.3, solving systems using elimination, day 1. I'm just going to briefly, though, review the 2 other methods that we know before going into elimination. So far, we know how to graph and solve a system. That's where I take both of my equations. I'll graph them on the grid, and hopefully, if they do, I try to find their point of intersection. That's the one ordered pair that will work for both equations. So maybe something like 5, 2. We can also get no solution or infinitely many solutions with that, but by graphing we can see it's a nice visual way to solve the system. We also can solve a system using substitution, where if I have one of the equations solved for a variable, like y equals 2x minus 3, then I can take and plug that into the other equation. So I could take y equals, that's 2x minus 3, and actually substitute in for y in the second equation, and then do some algebra and find our solution. And just kind of a quick review on substitution, just like other methods, like graphing, like substitution, and like the elimination one today we'll talk about. Sometimes they have to be set up correctly. Just remember, for substitution, you have to have the equation actually solved for a variable, or one of the equations solved for a variable, so you can actually use this method. Okay. I'm going to kind of skip down now and start talking about elimination, and we'll talk about what it takes to eliminate and how that works too. Again, just realize this is just going to be method number 3 for us. So it says, as it says here at the top of the slide, we know graphing, we know substitution, and now we're about to talk about elimination. And this one is exactly what it sounds like. We're going to try to eliminate one of the variables by adding or subtracting the 2 equations together. Maybe little did you know you could do that, but if I have a system of equations like I have below, I can just decide that I want to add them or subtract them, and one of the variables cancels out. I will be able to solve the system and find my x and my y, my solution. Okay. Now, if you need to pause the video here, I've got some things I'd like you to write in down below. Again, just like graphing, just like substitution, there's things that we need to have so that we can actually use this method. Number 1 is we have to have all the variables, the constants, and the equal sign lined up for both our 2 equations that we're using. So in this case, you can see that is the situation we have lined up here right now. I have the x's on top of each other, the y's on top of each other. Here's the equal signs, and here's the constants. So I have everything lined up. And then number 2 thing you have to have for this to work is you actually have to have a variable that you can eliminate by adding or subtracting. Okay, so let's take a look and see how this works. Again, pause it if you need to write down those notes. But you actually just stack the 2 equations on top of each other, just like we have here. I'm going to draw a line, kind of like an old school addition or subtraction problem. At this point, I have everything lined up, so now I just have to make the one big decision. Should I add or subtract these 2 equations together to eliminate something? And if I take a look here at the x's, adding 2x plus negative 2x is going to eliminate the x variable in this problem. So in this situation, I should choose to add my 2 equations together. Every problem you do, that'll be your one big decision you got to make. Should I add or subtract? After you get everything lined up, what will eliminate something? So that'll eliminate my 2 x's. Those will cancel out. And now I just add the rest of them, just like adding like terms. I get 8y. I bring the equal sign straight down. And 11 plus 13 gives me 24. Then I just keep solving, just like I would in the other equation. If I divide both sides by 8, I get y equals 3. Then, just similar to substitution, now I take my y value and I'm going to plug it back in. I'm just going to go up here where I got a little more space. I'm going to plug it back into one of my equations, and I'm going to pick the top equation in this case. Remember, it doesn't matter because it's a system, so I could plug this 3 into either place, but I'm going to use the top one. That one just looks straightforward enough. So I'm going to rewrite the top equation, 2x plus, but then I see this is 3y, and I just found out that y is 3, so plugging it in there, 3 times 3 gives me 9, and that would equal 11. Then I'm just going to solve it like a 2-step problem. 2x equals 2. So x equals 1. So my solution would be 1, 3. If I graphed these 2 equations by hand, I should find that they cross at 1, 3. If I use substitution to solve, I should figure out that the solution is 1, 3. Okay. Let's do another one here. This particular problem, again, everything is also already lined up for me. X's, Y's, equal signs, and constants. Again, that's not always the case, but these first examples we're doing are set up kind of nicely for us. So I'm going to draw my line and then make my one big decision. Should I add or subtract these 2 equations together to eliminate? If I'm looking at the Y's here in this case, 3y and 3y, I'd have to subtract those to be able to eliminate. So I'm going to make the decision that I am going to subtract. Okay. Now, I say that I'm going to subtract, but one thing that is easier for our brain, I know for sure easier for my brain and many other brains too, is that as opposed to actually subtracting, what makes this a little easier is just chop dashing the entire bottom equation. So as opposed to, because otherwise sometimes you end up with like negatives, you have to like do a negative minus another negative, and it gets a little confusing. Or I just find that students, by the end of the problem, as opposed to subtracting each term, they kind of lose track that they're doing that. So here's what we're going to do. Whenever you decide you're going to subtract, in this case that is the right decision, instead, just like when we chop dash other things, I'm going to chop this and make it addition. But then I just have to change all the signs in this second equation, because subtracting all those things is just like adding the opposite. And so I chop dash, I change all of them to their opposite signs. Now I can add, which is a little easier for our brain anyway. 4x plus negative 5x gives me negative 1x. The 3y's, like we talked about, are going to cancel out. That's what we're trying to do. They're going to eliminate. And now this is, at the end, just 2 plus 2, which is 4. Otherwise, it would have been 2 minus negative 2, which you have to, again, do a little more thinking to make sure you know what you get for that one. So it just makes everything a little easier. So I highly, highly recommend when you decide you're going to subtract, instead of subtract, just chop dash everything. Okay? Again, I'm going to take the negative 4 and plug it back in to x in the top equation. And so that's going to be up here. I'm going to get negative 16 plus 3y equals 2. I'm going to add 16 to both sides. Again, just like solving a two-step problem. I'll get 3y equals 18, so y equals 6. And my final solution then should be negative 4, 6. Okay. I'm going to try these next two right here. And again, you should maybe pause the video right now and just try them yourself, and then see what I get when I go through them here in the next few minutes. Okay. So, again, same idea here. I see that I have everything lined up. Yep, x's, y's, equal signs, and constants all in that top one. So I am ready to eliminate in this first problem. And I think that if I look at it carefully, the 7y's will eliminate if I subtract. But instead of actually subtracting, I'm going to chop dash everything. I'm going to make this addition, but I just have to change this 7x to negative, this 3y to positive, and that 4 to negative. It just makes everything much simpler. I highly, highly recommend you do that whenever you decide to subtract. First determine, yep, I got to subtract, but then go ahead and make your changes. Okay? That just leaves me then with y equals 1. So this one's kind of nice. I'm already done. I don't have to even do any dividing at the end. I just get y equals 1. I'll plug that back into the top equation. I should get something like this. 7x minus 2 is equal to 5. I'll add 2 to both sides. 7x equals 7. And so I end up getting x equals 1 as well. So this final solution, again, always write your final solution as an ordered pair, is 1, 1. Okay? And the final problem here, this one's the first one now where I don't have everything lined up. Right here, the y's, they're in different spots. The x, they're in different spots. So I've got to make them all lined up first. Notice that the first equation's in standard form. Sometimes I'll tell people just, well, if one of them's in standard form, maybe try to make the other one in standard form too. Because it just kind of seems to work nice. If I can get both the variables on one side, then I can flip-flop them if I want. So in this bottom equation, again, you don't have to do it this way, but this is the way I'm choosing for this particular one. I'm just going to subtract 4x to both sides. That's going to give me 4x plus 5y equals 6. I'll just bring the top equation straight over the way it is. 2x plus 5y equals 12. And then I can go ahead and do my elimination. Now I've got everything lined up. Yep, it looks like I can eliminate the 5y's by subtracting. So again, I'm going to subtract. But in subtracting, I'm really just going to chop and make add. I'm going to chop dash everything. This is going to be positive 4. It's going to be negative 5y, and this will be negative 6 at the end. Okay. Now when I start adding everything, I'll get 6x equals 6, because these 5y's are going to cancel. I'll just get x equals 1. I'm going to plug that 1 back in up here, just in some space that I got off to the side. So I'd have 2 plus 5y equals 12. Minus 2 from both sides. 5y equals 10. And so y equals 2. My final solution, 1, 2 for my answer.